Hello everyone. In this video, we're going to be solving a really nice problem from Russia. This problem is from a math Olympiad, a regional one, I think. We have x squared plus x plus 1 squared divided by 3x squared plus x plus 1, and the result is x squared. So we can solve this problem hopefully using two different methods, and I will start with the first method. So for my first method, I'm going to go ahead and cross multiply. And we're going to go ahead and expand everything, okay? By the way, before we get into the depth, I want to show you the graph of these two functions so you can kind of see what that looks like and what to expect. So here's the graph. I find one of the graphs actually very interesting. One of them is the parabola, but if you look at the other one, it's pretty interesting, like kind of like an interesting curve. That should be a rational function, but a really interesting one that has some asymptotes. I think you can evaluate them by division. Anyway, so that's going to be our first step. And if we expand it, that's going to give us x to the fourth plus x squared plus 1, and then 2x cubed, and then 2x squared, and then 2x. 3x to the fourth plus x cubed plus x squared. So let's go ahead and combine like terms. We could bring everything over here so that x to the fourth is positive. That gives us 2x to the fourth. And then we have 2x cubed and then 1x cubed. So that's going to be a minus x cubed. 2x squared plus x squared is 3x squared. If you subtract it from 1, you're going to get minus 2x squared. And that takes care of everything except for this x here, which is going to be coming over to the right hand side as minus 2x, and finally we have minus 1 equals 0. Great. We got a beautiful quartic equation. Good job. And now how do we solve it, right? There's a couple of ways to go about it. You can kind of try to depress this, like getting rid of the cubic term and then turning into a perfect square. Or we could use, if there are rational solutions, which I don't think so. We could use the rational root theorem, but for this particular problem, which we're going to look at later, the solutions, I don't think there's going to be any rational solutions. So we're kind of stuck. Obviously, sometimes you can factor by grouping. If you're lucky, I could try different groups like, these two and those two, because we have 5 terms, so that's kind of odd, right? Which is odd and odd at the same time. But again, you can try all these things. It wouldn't hurt to give it a try because you never know. But if you were to kind of eliminate the cubic term, you'd probably do it like this. I get minus 2x squared minus 2x minus 1 equals 0. You would replace, first of all, you want this to be monic, which means get rid of the coefficient of x to the fourth. Divide everything by 2. You're going to get something like this. And then now, here's where the magic starts. You can replace x with something like, let's see. Maybe you can use x something like, what am I thinking? I do need a light blue. Okay, here we go. Replace x with y minus, so here's the thing. You take this coefficient, okay, and negate it, and that's going to be 1/2, and then divide it by the degree of the polynomial, which is 4. So what is 1/2 divided by 4? That's 1/8, right? That's not light blue, is it? Kind of. I probably need a lighter one, but hopefully you can see this. If not, let me know. So I'll change it. And this should be what x is replaced with, right? So plus, I think there should be a plus sign. Anyways, if you do this, then the cubic term will disappear, and then you can try to solve it. But this is way too long. This is complicated, but not all problems are solvable easily, because the second method kind of uses something real cool. Let me show you. The first method, I'll leave it as incomplete, and I'm pretty sure there are other ways to do it. But let's go ahead and, take a look at the second method, because I think it's really cool. So the original problem, x squared plus x plus 1 squared. Again, just like with the first method, we're going to use cross multiplication. Let's do that. And then distribute the right-hand side, but do not distribute the left-hand side. I mean, you could, but it's not necessary because I'm about to divide by something. This is where the hocus pocus starts. First of all, one thing that's really good about it is that these two terms are repeated. Okay, so that's why this works nicely. You'll see in a little bit. So I want to divide both sides by x to the 4th power. See that? And now I want to write this as the numerator divided by x squared squared, because x to the 4th is x squared squared. And now on the right-hand side, I can write this as 3 plus 1 over x plus 1 over x squared. Beautiful. Now on the left-hand side, inside the parentheses, I can actually split this up as well and write it as 1 plus 1 over x plus 1 over x squared. And of course, don't forget it's squared, and then that's equal to this. Do you see what I'm talking about? I hope you do, because we're about to use a beautiful, beautiful method, which is called substitution. Yay! As for substitution. So now we're going to call this something. How about u? Let's use u this time, not coffee or tea. And this becomes u plus 2. Do you see? 1 plus 2 is 3. If you want, you can also call 1 over x plus 1 over x squared u and go from there. No big deal, but I like to call the whole thing u so that I can get u squared from the left-hand side, which is fairly simple, right? I don't have to expand it. And this is u plus 2. Now, you could probably guess and check at this point. I'm hoping you said, yes, u equals 2 is a solution, or u equals -1. But if you didn't get that, let's go ahead and talk about it. We could factor this. Remember, we're looking for two numbers whose product is -2, and their sum needs to be -1, the coefficient of u, which is satisfied by -2 and 1, and that gives you u minus 2 and u plus 1 equals 0, and from here you get the same solutions. Make sense? But these are just the u values, okay? We're going to go from these to x. How? By back substitution. Let's go ahead and back substitute. U equals to, what is u though? 1 plus 1 over x plus 1 over x squared. Nice. This is u, okay? This is not u, but this is u, the letter. And u is equal to 2. Great. So from here we can subtract 1 from both sides, and that gives us 1 over x plus 1 over x squared minus 1 equals 0. And then we can multiply both sides by x squared, right? Everything. And that gives us x plus 1 minus x squared equals 0. Negate, put everything on the right-hand side. X squared minus x minus 1 equals 0. How beautiful. Now from here we get, by way of quadratic formula, x equals -b plus the square root of b squared minus 4ac. That's a 5. Golden ratio coming up again. And the other solution is just going to be 1 minus root 5 over 2. Are both solutions valid? They should be, because we didn't square both sides, did we? No, we didn't. Okay, so those solutions should be good. But then there's more, right? You can also go ahead and set u equal to -1, which is going to be 1 plus 1 over x plus 1 over x squared. Set it equal to -1. Add 1 to both sides. 2 plus 1 over x plus 1 over x squared is equal to 0. And then multiply both sides by x squared again. Everything. 2x squared plus x plus 1 equals 0. And then by using the quadratic formula, again, you can find the solutions, so on and so forth. -b plus square root of b squared, which is 1 minus 8. That gives us complex solutions, right? Of course. Sometimes we get non-real complex solutions. Okay, that's fine, because it's a quartic. That happens sometimes. So we have 4 solutions, as you can see here. If you want to see them all together, let me go ahead and zoom out a little bit so you can see them all together. Can you? I hope so. And then this almost brings us to the end, but I want to show you, ta-da, from alpha, the solutions. 2 real and 2 complex. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.